Hello, and welcome to this video on lake deposits. From lake deposits, we get sediment cores, fossils, ash, pollen, and more. We can reconstruct the biosphere and climate of the past while recording geological history. With knowledge of the trends of the past, we can predict the consequences of anthropogenically induced climate change. This is a sediment core from the Japan times that shows us the rock layers through time. Let's examine our first region. Our first region is Clarkia, northwestern Idaho, is pinpointed here by Google Earth. Our publisher, Smiley Charles J. et al. In 1975, found large animal fossils, diverse pollen, and evidence of once active volcanoes from the Miocene period. That's here on the geological timescale from the Geological Society of America. Here are some of the images from the journal published by Smiley. In the upper layers of the lake, there was iron staining in the rock, as this photo from Robert Padalano shows us, suggesting high oxygen levels in the higher layers. Here are some of the plants discovered. These plants had large leaves, like those from a warm climate. Smiley et al. Found insects, larvae, beetles, leaves, small fish, seeds, flowers, fruits, and more. With so much evidence of the past, we can start to reconstruct the climate. The iron staining plus the multitude of large-leaved flora indicate a highly oxygenated, warm, wet environment. According to Smiley, this environment resembled the current U.S. Gulf coastal area. This is a photo of a typical warm, wet environment from Lumen Learning to help us picture what it might have looked like. According to U.S. climate data, today Clarkia experiences very seasonal weather with hot, humid summers, as we can see in this image from All Trails, and cold winters, as we can see in this image from the Wikipedia page on Clarkia. The Köppen climate classification subtype for this climate is DFB, according to NOAA. According to a scholarly article titled Observed and Projected Changes in Idaho's Climate, the state has seen its warmest 21 years since 2000. More extremes in weather are predicted for summers and winter, while certain types of droughts are also expected to increase. Here's an image of Clarkia today from Realtor.com to help us picture a drier Clarkia. Now let's travel to South Africa to Lake Lange, which, as we can see from this Google Earth pinpoint, is in the northeastern corner of the country. At Lake Lange, the lowest layers of the sediment cores date back to the late Pleistocene to the mid-Holocene period, about 126,000 years ago, and that's here on the geologic timescale. On this image on the left, we can see the shape of the lake bed and all the different places they took cores from. This image on the right here shows the layers of the sediment cores from one core sample. The publisher of the findings, Ian Wright et al. In 1999, found a transition in the layers from one type of environment to another. The first core sample showed a change from bottom to top, from deep water, a sheltered lagoon, to receiving sediments from freshwater rivers. Higher up in the core, mollusk-like creatures were found, suggesting a tidal region. This is a great example of how lake deposits can help us reconstruct huge events and changes in the geologic record. We can reference a similar event in Spain to help illustrate what that transition might have looked like. As covered by CNN, a lagoon is being flooded by a river, just like the evidence suggests happened at Lake Lange. This last image on the right is from Escape to Kosi, a nearby region, to show us how shallow the lake became. We can see, according to this map from ResearchGate, that Lake Lange is a CFA in the Köppen classification system. It is warm, temperate, and fully humid with a hot summer. Here's an actual image from iStock of Lake Lange today. According to a chapter from Sustainability of Southern African Ecosystems Under Global Change, we predict less precipitation going forward, resulting in an expansion of this orange area into the lake, meaning the area will become drier. Now let's travel to our final destination, West Germany, to the lake deposits of Grube Missel, where vertebrates from the mid-Eocene were preserved so well that even their stomach contents were visible. This time period was about 40 million years ago. The publisher, Franzen J. in 1985, found fish, turtles, crocodiles, frogs, snakes, birds, and bats, pictured here. The presence of dinoflagellates depleted the oxygen at the bottom of the lake, meaning preservation conditions were excellent. So what do the creatures tell us about the climate at the time? The Köppen climate classification for this environment was likely CFA, humid and subtropical. This is an artistic rendition from the University of Kansas of the creatures from this time period to help us envision the past. We can see, according to this map of the climate classifications of Europe from Climate Change Knowledge Portal, West Germany is classified as a CFB, which is temperate oceanic climate. This means there's consistent precipitation throughout the year and it doesn't fluctuate by the seasons. It is much colder and rains much more consistently today than it did millions of years ago. Here's a picture of the region today from my travelogue. What is predicted to happen to this region going forward? According to Climate Change Post, temperatures are expected to increase several degrees by the end of the century. This is an image of the region from Wikipedia, which can help us imagine the lake becoming drier. Through sediment cores, fossils, ash, pollen, and more, we can reconstruct the biosphere and climate of the past while recording geological history. With knowledge of the trends of the past, we can predict the consequences of anthropogenically induced climate change.